Collision avoider robot. As the name says, it uses ultrasonic sensor to find the object in front of the robot and avoid colliding. This structure has two sensors so that when any object is detected on the left sensor, the bot moves rightwards and move left if something is sensed on the right sensor. If there is some object sensed by both sensors, it means that there is no way and the bot stops. Light follower robot. Again, this uses photodiode to sense the light intensity and follow the path where the intensity of light is more. If left sensor intensity is more, then the robot moves towards left. And when the right sensor sees more light, then it moves rightwards. By default, the bot is designed to move straight if the intensity of light is below the threshold. Automatic streetlight control. This project illustrates the streetlight control system depending on the vehicle movement. This is an energy efficient method of controlling the street lights by detecting the vehicle movement on the roads. The set of ultrasonics are placed on the roads to detect the vehicle movement. The sensed data is processed in the microcontroller and accordingly it switches the street lights. Also, LDR is used to save energy during the daytime by not activating the street lights during the day. This project needs an LED fixed to the green pole, LDR above the LED structure, ultrasonic sensor kept on the vicinity of vehicles, and an Arduino that controls the LED. As the vehicle approaches the ultrasonic sensor, it activates the LED after processing in Arduino. Also, there is a check in Arduino if the LDR value sensed is a day or night. That is, the LED will be only on if LDR senses a dark threshold. Parking lot control. This project is used to regulate the count of incoming vehicles in a parking lot depending on the availability of space. The count increases for each incoming vehicle and decreases when the vehicle moves out of the parking area. Hence, in a multi-level parking area, you can park the vehicle just by seeing the availability in an LCD screen. Here, we have used two ultrasonic as the sensor shown in the red box. For each vehicle under vicinity of sensor, a count will be increased on yellow side, which acts as an entrance, and decreases count on crossing the green side, and thus showing the actual count in the LCD attached to the Arduino. Welcoming robot. This project implements the automatic welcome with the detection of human presence. When the distance calculated from sensor reaches the threshold, the servo motor is given with 90-degree angle to lift the hands up. The sensor we have used is an ultrasonic sensor. The red area shown in the pic denotes the sensor that senses the object under vicinity, and the yellow parts are the servo motor that will control the hands of the robot when ultrasonic sensor senses an object. Instruction control robot. Robot will be in the center of the map, and based on the card color shown to the IR sensor, the robot will reach the destination. Every time, position the car at the center of the map after reaching the destination. So the implementation is like we should have 4 color cards and let each color point to a destination. When a color is shown to the robot, it will display the destination to reach in the LCD. Then press the push button to start moving to the respective location after fixing it. Automatic washing machine. This project implements the operation of a normal washing machine. We need two DC motors in which one motor will have a water pump mechanism attached as shown. For reference, look at the following video.
DC motor 3 to 6 volt. Low noise motor, not much noisy.
Another DC motor will be attached to a robotic wheel and will be surrounded by a cylindrical chart that gives it a structure of washing machine. There are 3 push buttons. One is for starting the washing machine and other 2 are for selecting the mode. Button 1 is for selecting hard mode, which rotates the motor 5 seconds forward and 5 seconds reverse. Button 2 is for selecting soft mode, which rotates the motor for 2 seconds in forward and 2 seconds in reverse direction, and both will be running in loop for 3 times. After selecting the mode, we have to press start button. The initial operation is to fill the washing machine with water, which will be done by the pump motor. Note that this is just a model and we will just have a small tumbler to collect the water inside the washing machine. Let the water pump be on for 5 seconds. Then let the operation of other motor start, which works depends on the mode set. Lift. This is just a model of how a lift works, and for this we need 4 push buttons and each button corresponds to a floor that the lift stands. Setup is done with a bobbin that is attached to a DC motor shown in orange color and blue color on the pic. Long string fastened will carry the lift as shown. There are 4 levels marked in white color band. Level will be selected using push button. Sweeping robot. This project implements a small remote controlled sweeping robot that uses universal remote control with TSOP1738 sensor to control the robot that has a small broom at the front side. The remote control numbers may vary. See the LCD for each button press and find the value to insert in the if case of the code block. This project also integrates extra functionality to merge with automatic traffic control project, where it uses ultrasonic sensor positioned to its right to stop automatically when the strip is perpendicular to the signal red. Check the project for more info. Automatic traffic control. When signal is red, the thick yellow stick controlled by servo motor comes to 90 degree, that is perpendicular to the surface, else will be in 0 degrees, that is parallel to the surface. This will be implemented by sweeping robot. Car, in our case robot, will have an ultrasonic sensor facing rightwards as shown. When the signal is green or yellow, the car can cross the white line and move front. But when the signal is red, the car can't cross the white line as the yellow stick position is perpendicular to the surface. The stick height is under the proximity of ultrasonic sensor attached to the car, so the car cannot move after that. When the signal is green, the stick will go down and will move. The program to be done here is simple. It is just like when the signal is red, the respective servo motor position should be perpendicular to the surface, such that the yellow stick is pointing 90 degrees towards the surface. Tea coffee vending machine. This project is just a model to show how an automatic vending machine works. This needs 3 push buttons, one for coffee, one for tea, and another to start the pump. First, select whether coffee or tea, then select the start pump button to pour the coffee or tea on a glass. This is just a model and we can use colored water instead of actual drink.